Okay, so for our next lesson, we're going from the very shallow end of the matrices paddling pool to the very, very deep end. So last class, you were just plussing, minusing, and multiplying matrices together. What we're going to do now is kind of apply some of that stuff and a whole lot more to transforming some graphs with the use of matrices. Mainly, we're not really worried too much about the graphs themselves, but the actual equations behind them. Uh, we're going to be looking at how we can use our knowledge of matrices, which we acquired on Tuesday, to take some information about a graph and create a transformed equation. So let's dive into this deep end. Hey, so look at all this stuff on the screen. This is some information that will help you apply the different transformations that can happen to a graph. Uh, it looks like a lot at the moment, but once you just kind of go cross-eyed and just have a good close look at it, you'll see what this is all telling you. So essentially what we're going to be doing is setting up a series of matrices next to each other, and you guys just have to learn which matrices and which numbers have which transformative effect on the equation. So from our previous work with transformations, we know that our graph can be just moved up and down, side to side, through a translation. So I'll show you where that part is on this slide. We're going to be looking at a matrix, uh, which is a 2 by 1, and this matrix will be added to a matrix that has the letters x and y in it. So just so you know, every single equation has x and y in it, so every single matrix setup of equations has x and y in it, so look out for your x and y matrix all through your work. So if you see a matrix after that x and y that's being added to it, then that's going to have the effect of moving it sideways or moving it up and down. There's also going to be some multiplication matrices in front of the x and y, as we can see in these examples here. Okay, so all of these examples have a multiplication matrix just in front of x and y, and these can do two things. So they can dilate it, which is the effect where it goes up faster or it's flatter. So essentially, if there's any number in these matrices that isn't the number one, then there's going to be a dilation, which means it'll either be going up faster and steeper, or it'll be going up a bit flatter, depending on whether there's a whole number or a fraction there. So look out for that, and also look out for negatives in this multiplication matrix. If we are multiplying by a negative, what that means is there'll be a reflection, which means our graph will either be flipped left to right if there's a negative in the top row, or it'll be flipped up and down if there's a negative in the bottom row. For you guys this year, don't worry about this one so much. Okay, you can cross that one out or just not cut it out when you stick it in your book. Okay, so this is going in your glossary just so you know that you're going to have an x and a y no matter what. In front of it, there's going to be a matrix multiplying. Usually the number 1 will be there. If it isn't the number 1, there is a dilation. Usually it'll be a positive number. If it's a negative, though, it's a reflection. And then right after x and y, you could see a plus matrix. And if there's numbers in that, that's a translation, moving it left and right, up and down. Okay, so we'll figure more of this out as we get into the worked examples. All right, so before we get into our first worked example, here's just a little summary of what I was trying to explain, because sometimes having words alongside some more mathematical diagrams helps to understand it. So understand that there will be an x and a y matrix, all right, a matrix sitting in the middle of all our work with x and y in it. That's because we have our x-axis and our y-axis, and we're working with equations that link with graphs. So there will be a square 2 by 2 matrix in front of it doing a multiplication. Numbers that aren't 1 perform a dilation, and negatives do that reflection. Okay, we won't have to visualize what that looks like on a graph today. We just have to be able to take words like dilation and reflection and actually interpret them and put them into a matrix ourselves. There will be a 2 by 1 matrix added afterwards to show translations. It'll come after the x and y, there'll be a plus, and then you can put negatives in that if you want it to move backwards or move it down. So just know that any transformation that is applied to the letter x, the variable x, is going to be a side-to-side movement. Okay, so it'll be a side-to-side dilation, stretching it out, or it could be reflected side-to-side, or it could be translated side-to-side. Basically, anything in the top row of any matrix is going to be a side-to-side movement, and anything in the bottom row then is going to be getting done to the letter y, and that's going to be an up and down translation. um, or reflection, or um, dilation. Okay, and just know that when we've done transformations in the past, side-to-side movements have been in reverse. Okay, so like if there was like an x take away 5, we were going positive 5. With matrices, we don't do that. Matrices don't work backwards when we set them up. Matrices are nice and honest. So if you're told to go backwards 5, you put a -5 in your work. Okay, with all that said, let's do some worked examples to try and actually figure out what's going on here. Okay, so there is going to be a lot to take in that's new today, but you guys are going to do okay as long as you can get your head around the words, the dilation, the reflection, and the translation. We have worked with those with our transformed graphs before, so if you know those words, you'll be okay, because we're going to show you where to put the right numbers in your matrices. You'll also be okay if you like following steps and following instructions, because I just have 6 steps for you to follow to actually do this transformed matrix method to turn what's a basic equation into a transformed equation. So generally a question like this at your level will give you a standard graph. So this one is 1 over x. It's the most standard hyperbola that there is. There are no transformations there in that equation. Then you're being asked to use matrices specifically, right? There are other ways of transforming an equation, but we're learning about matrices. So you're going to use matrices to find an equation if I transform my function. So we are going to dilate this by a factor of 2. That just means the number 2 is involved, parallel to the y-axis. So you've just got to read it very carefully. Think about your left and right, your up and down. So if we have a Cartesian plane drawn up, think about which direction is parallel to the y-axis. So any line that is parallel to the y-axis is a line kind of drawn up and down here. So what that is telling us is that we're doing a dilation that goes up and down. Okay, so when we're working up and down with a transformation with matrices, we're doing something to the letter y. Okay, so that's kind of our starting point with our thinking. Okay, we're going to put a number somewhere on the bottom row, so that number transforms the letter y. Okay, so the first thing you've got to be able to do is set up a series of matrices. Okay, so we put a big T there to show that we're transforming. We are transforming x and y. And what we're going to be getting involved here is we're going to be getting involved these kind of new symbols that you haven't really seen before. Well, this year in this subject anyway. They're called x dash and y dash, and these are kind of like placeholders, basically for any particular point that might show up on your graph. These are apostrophes, they're not the number 1. Okay, it's not x to the power of 1. It's an apostrophe, and we call it x dash, we call it y dash. Okay, so they're going to be involved in a minute, and you'll see why with our working out. What we want to do now is set up matrices that represent the maths we've been given. Okay, so there's generally going to be a multiplication matrix at the front. If we're not dilating or reflecting, we put the number 1 in the corners. But if we are doing something, okay, so these ones are always going to be zeros for you guys. Okay, because of the way matrix multiplication works, we just want zeros there. But there has to be a number here, there has to be a number here. If we're not doing anything to that particular letter, x or y, leave it as a 1. If we are doing something to that letter, x or y, we've got to actually show that transformation. So that's where this 2 is going to come into it. This 2 is dilating up and down, so it's dilating the letter y. So instead of a 1, we're going to just put a 2. All right, simple as that. So whatever they tell you you're dilating by, put the number there in the right spot. Okay, if I was dilating side to side, I'd put it there in the top row, but I'm dilating up and down, so I put the 2 there. What's going to come next is your x and y matrix. Okay, this setup of our matrices always looks like this. You're going to have a multiplication matrix, then one with x and y, and then if there's any translating going on, so I'm moving it side to side or I'm moving it up and down, I'd be plussing another matrix at the back. That's not mentioned here, so we're actually done setting up our matrices. Okay, what we do now is we use these matrices to find the equation. So we're going to follow these 6 steps. Okay, so we're going to do step 1. Step 1 says use the matrices to express what's been done to x and y. That really just means if you've got some matrices that are multiplying or they're being added, just actually do the maths with the matrices. Okay, so we're just going to multiply these 2 matrices together, and the output's going to be pretty straightforward. Now, we have put this thing here with an equal sign because that's what's going to be involved with these equations we're going to make. So I want an answer for x dash and I want an answer for y dash when I multiply these matrices together. Okay, so if I multiply these matrices, you can do it in your calculator, or you can just know that this 1 is going to times x and this 2 is going to multiply by y. Basically, 1 times x is x and 2 times y is 2y. Okay, so essentially if I did multiply those together on my calculator, it would spit out the answer x. You can do this with letters, your matrices don't mind it. You'd get those there. So essentially what I'm saying is I would have multiplied these together and got x and 2y, which means that x dash, just this top row, right? I'm basically putting this top row together, that x dash equals x and y dash equals 2y. Okay, that's step 1 done. Okay, and it's actually step 2 done as well. Okay, step 1's kind of doing the matrix multiplication. Step 2 is then writing these equations from it. Step 3 asks me to rearrange the equations, these new things that I've made from my matrices, and I want x and y as the subjects. I don't want x dash and y dash to be the subject. I want to transpose this. We get to practice transposition a bit more, because I want x to be by itself and y to be by itself. Now this one's already done. X is already by itself. We'll just put it on the left-hand side to just show that. Okay, so x and x dash are the same thing. This one's going to need some rearranging. I want y by itself. There's a 2 next to it. I've got to divide by 2. So when I do that, y will be by itself. And on the other side, after I divide by 2, I'll have y dash on top of 2. Okay, so I've done step 3. I rearrange these equations to get x and y as the subjects. What I want to do now is I want to substitute these rearranged equations. So we want to substitute this and this into my original equation. Our original equation, don't forget, is all the way back up here. Okay, we're working with y equals 1 on top of x. And we've got these rearranged transposed equations that came from our matrices, and they're telling us something that x or y are actually equal to. So we're going to substitute both of these things into this rearranged equation. So instead of y, I'm going to be writing y dash on top of 2, because that's something that y is equal to. And I'm still going to do it with this, even though it doesn't change much. I'm going to put 1 on top of x dash. Okay, step 4 is done. Okay, so whatever you get from this rearranging goes into your original equation. Okay, now we have to do some more transposing, some more rearranging. We need to make y dash the subject. Okay, a lot of just making particular things the subject with this method here. So to get y dash by itself, we've got to get rid of that 2. So that 2 is dividing my y dash. I need to multiply both sides by 2. Right, we're going to be going times 2 on this side here. So we know it has this effect. It crosses out that 2 there. So I've just got y dash by itself, which is what we're after. And on this side, if I times this fraction by 2, it just turns the top into a 2. And then we want to write a nice equation that just has y and x, not y dash and x dash. They've served their purpose. They were like placeholders for x and y while we did our work. Now we can just remove the dashes, scrub them out, and we get our transformed equation. Y equals 2 on top of x. From the very, very start, this question was really just saying we want to dilate by a factor of 2. Which means we want it to be twice as steep. And we have learnt previously that making something twice as steep just involves timesing by 2. So we probably could have seen that from the start. We just needed to double the equation. But what we're trying to practice is this somewhat complicated matrix method. Okay, we've got these 6 steps to follow. These examples do take a while for you guys to sit through and follow, but we'll do a few more just because it's so new and there's so much going on. All right, let's follow this painstaking process again to do something that's actually somewhat simple. This is a pretty basic transformation. We're only doing one thing to this equation. We've got x cubed, which we know normally looks like this, and we're going to be reflecting it in the y-axis. So it's really important to get your head around whether these transformations that have been done to your graph, are they being done up and down, or are they being done side to side? Okay, now this says that we're reflecting in the y-axis. The y-axis is, as we know here, right? This is our y-axis. And we're reflecting in this. They're saying this is like your mirror line. So basically, if this is my graph, we want it to be reflected in that axis. We just want it to flip left to right. Okay, we want our graph to look like this. The most important thing for you guys to know, though, that this is a side-to-side transformation, right? We're flipping it across the y-axis, which means for a side-to-side transformation, we need to do something to the letter x, not the letter y, to the letter x, because we're moving side to side. So that means when it comes time to do some matrix work, which we will right now, we need to put our transformation in the top row, because things in the top row transform sideways and do things to the letter x. So again, here's how you set up your matrices. You need a big T for transformations. We're transforming x and y. We're going to be doing it through the use of the variables x dash and y dash as their placeholders, and they help us transform the image. And let's just make sure we put things in the right spot, right? We've got this multiplication matrix we need to set up. We are not dilating, we're not making it steeper, we're not making it flatter. We just want the number 1 in both spots. Okay, these are always zeros, and this is where our transformation action happens if there's any. We're reflecting in the y-axis, and as I said before, we're reflecting side to side, which means that we need to put our reflection in the top row. Okay, so a negative there will reflect it side to side. If we were reflecting this graph vertically, up and down, we then need to put it in the bottom. We got x and y. There are no translations being done, so we don't plus a matrix at the end. That's it. That's our matrices done. And we're ready to follow our 6 steps. Okay, so we want to actually multiply the matrices together. Step 1 is to times this by that. Okay, so when I multiply these things together, x is going to get multiplied by -1, and y is going to get multiplied by 1. Okay, so when I do that, I get negative x. That is what happens when I times -1 by x, and 1 times y is just y. All right, step 1 is done. We've used the matrices by multiplying them together. We're going to write these two expressions in terms of x dash and y dash, because that's what these are equal to. This is the equals part of our equation, our matrix equation. So x dash is equal to -x, and y dash is just equal to y. Right? Nothing actually happened to the letter y. The only thing that happened to x is it got turned into a negative, but that means we've got some work to do. All right, we want to rearrange these equations to make sure x and y are our subjects. We're pretty happy with this bottom one already. We'll just flip the left and right. Y and y dash are the same thing. All I need to do to get x by itself here is get rid of that negative. So I'm basically going to times both sides by -1, or just say I'm going to flip all negatives positive. X is going to be equal to negative x dash. Step 3 is done. We need to work with our original function. Right, now that we've finished clarifying our matrices and rearranging stuff, we go back to our original equation, which was y equals x cubed. And then we need to substitute these elements into that equation. Okay, so we've got y dash on this side, and we've got negative x dash. Put that in brackets and we'll say it's cubed. There, okay, so I've turned my x into a negative x dash. Let's just see if we've got any maths that really needs doing. What we can do is we can kind of get rid of these brackets, right? It's good to have brackets when we're substituting something for something else, but now we can see what effect the cubed will have on what's inside the brackets. So we know that any negative cubed stays negative, so we might as well just get the brackets out of there. Y dash is the same thing as negative x dash, and that's cubed. We did need to see if we could rearrange to make y dash the subject. As soon as we substituted it in, though, y dash was already the subject. It was already by itself. There was no rearranging or transposing to be done there. So the last thing we've just got to do is replace y dash and x dash with y and x. Okay, so rewrite it as y, negative x cubed. Okay, so a whole lot of work when most people just know by the time they've studied transformations in year 11 and 12, it's automatic knowing that a reflection that goes left to right, you just put a negative in front of your x and you're done. Uh, so it's a nice simple example, I guess, of a transformation, uh, learning the complicated method of using matrices. All right, so there's another one done. So to help you with a couple of more complicated examples that we've got for you from today's work, that'll help you get through the chapter. We've just got this slide here as well, just to show you what a fully fledged kind of 3 transformations in one go kind of matrix setup looks like. So what you might see looking in your book at some examples or just in the questions that they set, they might put the 2 multiplication matrices here next to each other for a start. That's just to show that there are reflections happening and there are dilations happening. We can see from this first matrix there's a negative down the bottom, which means it's been reflected up and down. There's also a 2 at the bottom, which means it's been dilated up and down. And then at the back of it, once all this reflecting and this dilating's happened, there is some translating going on. This graph is being moved sideways 1 unit and up 1 unit as well. So there's reflection, dilation, and translation happening. Now, more commonly, what you should see and what we want to do to make our work simpler, if you get given 2 of these, and like there's no brackets or funny business going on, then these 2 matrices should be combined to show the 2 effects or the 2 transformations in one. And we can do that by just combining the numbers, basically by multiplying. So if there's a 1 here and a 1 there, there's going to be a 1 in that spot. Nothing's happening to x in terms of reflections or dilations, so the number 1, we'll just keep it as 1x. There's always zeros here and here, always, no matter what. And minus 1 and 2 make negative 2. And this negative 2 tells me 2 things. It tells me there is a reflection and a dilation, both happening to my letter y, which means I've got 2 transformations there happening in terms of my up and down on my graph. Okay, so this is a matrix that tells me that we have a reflection and a dilation and some translations happening all at once. All right, so here's a more complicated example, and it might show you why matrices are actually useful, because our last 2 examples, we took something that was very easy and it made it very, very complicated by introducing matrices when we could have just put a minus in front of something or put a 2 on top of something. What we've got is a combination of transformations. So if we want to use matrices to deal with this cube root function, we want to dilate it by a factor of a half, parallel to the x-axis. We want to reflect it in the y-axis. We want to translate it 2 units right. So we really have to be thinking whether we're moving side to side or whether we're moving up and down. I might just set up kind of a blank template, I guess, of our transformation matrices so we can put things into it once we figure that out. So we're transforming x and y. We're going to be doing it through the use of x dash and y dash. These are going to substitute for x and y and help us do some rearranging and stuff. We are going to have a multiplication matrix. We've always got zeros here. We'll have to figure out what goes here and here. We always have x and y in this spot. Right? And this is a good way to think about it if you're getting confused by all this, that your matrix setup always looks like this. None of these details are ever going to be different when you set yours up. X and Y is always here. We've got some multiplying going on here. And then if there's mention of translations, there'll always be a matrix being added after it as well. So let's just quickly figure out whether we're moving side to side or up and down. Okay, so if I've got a plane here, let's just think about what this language means. Right, we've got to interpret this. We're dilating by a factor of a half, so we're going to be putting a half somewhere, parallel to the x-axis. Right, so the x-axis is here, so anything that's parallel to the x-axis is moving here, side to side. So side to side transformations go in the top row. All right, I'm going to put a half here. There is no mention of a dilation in the other direction, so we have to put a 1 here on the bottom. We're reflecting in the y-axis, right? So again, the y-axis is our mirror line, right? This is our mirror line here. We're reflecting across that, which means we're reflecting side to side, so we have to put the negative in the top row as well. And we are translating 2 units to the right, and of course right is a left and right movement as well. So we're translating 2 units right. Right is positive, right? That's where positive numbers live, so we put positive 2. There's no mention of a translation up or down, so we have to put a 0 here. Okay, so nothing's been done to y at all. Everything's been done to x. All of our transformations are side-to-side transformations. We're now going to try and make the equation following the usual steps. All right, so step one involves doing some matrix work. So we're going to be multiplying this matrix by that one, and then adding that one to it afterwards. You can trust your calculators on this. Feel free to type it all in with the letters x and y. It will give you what the answers are. But just know that basically the top row is going to go together and the bottom row is going to go together. So x is going to get multiplied by this number and have that added to it, and y will be multiplied by this number and have that added to it. So the answer that comes out the other end, I'll just chuck it down here. Basically, the half will go with x because they get multiplied, and the 2 will be added afterwards. And also, the 1 will multiply y, and nothing gets added to it, so it's just y. Not much going on there, which will make things simpler for us as we move through our steps. So step one is to actually do your matrix maths, right? Actually equate them all together. Now we will write the expressions as x dash and y dash, write them in terms of that. So we just say that x dash equals the top entry. Right, so x dash equals negative a half x plus 2. You can see this is where all the work's going to go. And y dash equals y. All right, step 2 done. We now need to do our transposition, really only with the x's and the x dashes, because y is already equal to y dash. So got a couple of steps to get x by itself here. Okay, so the first thing that we'll do, other than the fact I've swapped the left and the right hand side, is I would be subtracting 2. And then what we've got to do next, we can do all this in one go if we want. We basically just need to multiply both sides by negative 2, right? If I want to get rid of multiplying by a half, I can just multiply by 2 to cancel it out. And since there's a negative there, we might as well multiply by the negative at the same time. So we're going to multiply the whole thing by negative 2, okay, to get x by itself. So on the other side, we'll have negative 2, multiplying the entire side. X dash take 2. And then we'll actually expand that bracket out. So we've got negative 2 lots of x dash plus 4. And thankfully this one needs no rearranging, so we can just say that y equals y dash. Okay, we've got our rearranged things that we can now work with for the next step. Right, so this step here is done. We need to substitute our rearranged equations. So we need to substitute these x dashy y dashy things into the original function that we were given. We were given cube root x. So instead of y equals cube root x, we've got to put y dash, because that's what's equivalent to y. And then we've got to put the cube root, not of x, but of negative 2x dash plus 4. All right, we've substituted them in. We have to make sure that y dash is the subject, and thank heavens, since nothing much happened to y to make it into y dash is already the subject, so we are good, and we just need to rub out the dashes. We don't want y dash and x dash at the end, we just want y and x at the end, and we're done. So we've got the cube root of negative 2x plus 4. So essentially this is the equation I would get if I started with cube root x, and I dilate it by a factor of a half, so I'm kind of flattening it out side to side. I wanted to reflect it side to side, and I want to move it to 2 units to the right. Okay, so doing those 3 things to my graph or my equation gives me this answer. Okay, and matrices helped me get there when I might have been stuck otherwise. The last example for this video is taken from your textbook, just so you can get used to the way they're going to ask the questions and some of the language that's involved and the way they've broken it into part A and part B. With part A, they're asking us, what is the transformation for a translation of 2 to the right and 4 down? reflection in the x-axis, and vertical dilation by a factor of 3 in that order. So they're giving us a few different transformations. They're giving us translations. So there's going to be movement side to side, to the right and down. Okay, so we're going to be filling up that plusing and minusing matrix. There's going to be a reflection in the x-axis. So that means the x-axis is our mirror line, which means it's an up and down reflection. And we want a vertical dilation. So again, up and down dilation by a factor of 3. But they said in that order. So that's a little wrinkle. We'll deal with that when we get there. We might just set up our matrices. That's what they're asking for in part A. What is the transformation? Show me the big T, show me the matrix. So we're transforming X and Y. We're going to be transforming through the image, X dash, Y dash. We need to have a multiplication matrix set up. And the multiplication matrix, that's where we get our dilations, because that's multiplying, and that's where we get our reflections, because that's our negatives. Better put our zeros there. We did just talk about the fact the reflection is in the x-axis, right? So we're reflecting across the x-axis, which means we're reflecting up and down. We're also dilating up and down vertically, which means everything's going into this part here. So there's a reflection, so you put a negative. There's a dilation, so you put a 3. Nothing's going on side to side right now. This is where X and Y come into it. And then we've been told that we are translating 2 units to the right. Okay, so that's positive. To the right on our graph is the positive number, so just put positive 2. And we're moving 4 units down, so you need negative 4. Now, the problem here is that they said things have to happen in that order. So the translations have to happen first. And we know from BODMAS still applies to matrices. If we don't do anything, the multiplication's going to happen before the addition. Thankfully, the solution's not too tough. Just put brackets around these matrices to make sure they get added together first. All right, so that's A done. All right, we're going to solve part B now. Right, this was part A here, making the matrices. Part B, apply the transformation to find what the curve with the equation 1 on top of x squared, right, so a nice truncus, is mapped to under the transformation. Okay, so we want to just make a new equation using this instructions and using the matrices to help us do it. All right, so step 1, use the matrices to actually get x and y out the other end. Okay, so again, I would encourage you, right, if this is feeling overwhelming for you guys, don't be afraid to just use your calculators and actually just type them in. So the main difference here, you have to put brackets around these, so the plusing and the minusing is going to happen first. It's not going to matter so much for your x, right? There's just a 2 being added to it, then it's being multiplied by 1. Okay, and multiplying something by 1 doesn't really do a whole lot, so it's just going to be x plus 2. What's going to happen here? The y will have the 4 subtracted from it first. But then, after that 4 is subtracted from the y, the whole thing's going to get multiplied by negative 3. Okay, so if you're doing it by hand, it'll look like this for a start, but then we should actually do the times by minus 3. Expand those brackets out. So we'll have x plus 2 as our top entry, and then we'll have negative 3y. Right, I'm timesing that negative 3 into these brackets here. Right, it had to happen after the take 4 happened, whereas previously, if there were no brackets there, it would have just been negative 3y, take away 4. Because the minus 4 had to happen first, we've got to have the minus 4 there. Then it gets multiplied by minus 3 when I expand it out, so I end up with plus 12. Okay, so we've done the matrix business. We'll write these expressions in terms of x dash and y dash. Right, we'll move on to that step there. So we're saying that x dash is equivalent to x plus 2. Right, I'm really just writing down these parts here. And y dash is going to be equivalent to negative 3y plus 12. What happens next is we need to rearrange these equations to get x and y as the subjects. So we're going to have to do something to both equations in this case. So we want x by itself. We don't want that plus 2 there with it. So we're going to subtract the 2 from the other side, and the y needs to be by itself as well. We'll have to do that in 2 steps. So we're going to be subtracting the 12 first. So put the y's there, right? Minus 3y equals y dash. Take away 12. And then we're going to divide both sides by negative 3. So y will equal, right? That's how I get rid of the negative 3, right? Divide by negative 3, just cross it out. I know some of you guys like still seeing this working out here, right? Dividing this side by negative 3, dividing this whole side by negative 3, right? Not just by 3, but by negative 3. So that'll basically have the effect, try and get my green pen back. You'll have negative y dash plus 12 all on top of 3. All right, so the effect of dividing the whole side by the negative, it'll flip all your positives into negatives and all your negatives into positives. Then you can put the whole lot on top of 3. Okay, so the 2 parts we're going to be working with here, we're going to be working with this one because it's got x by itself, and this was an in-between step. We're going to be working with this. This has y by itself, and we can move on. We've made x and y the subjects. We can get on to step 4. All right, so now that we've got our x dash in our y dashy expressions, we've got our x dash take 2, we've got our y negative y dash plus 12 on 3. These can now be substituted into our original function. So our original function was your basic kind of truncus. So it was y equals 1 over x squared. So we're going to be replacing x and y with whatever they are in terms of with x dash and y dash. So we're not going to be working with y for the time being. We're going to be working with negative y dash plus 12 over 3. And on the other side, it's going to be 1 on top. This is why it's good to put substitutions in brackets. I'm turning x into x dash minus 2. And that whole thing is squared. All right. Step 4 is done. We've substituted, right? We turned y and x into something that isn't y and x. We are on the home stretch now, I promise. We've got this set up here. We've only got a few more steps to go. We need to do some rearranging. We need to make sure y dash is the subject. Right now, y dash has a negative and a 12 and a 3 with it. So let's knock these things off one at a time. First thing to do will be to get rid of the 3. We're going to multiply by 3, and we're going to multiply this side by 3 as well. Right, it's going to cross that out. All right, let's write down what we've got. So on this side, we've still got negative y dash. We've still got plus 12. And when I'm multiplying a fraction by a number, like 3, let's just make the numerator 3 times bigger. Right, this is a fraction that's 3 times bigger than what I had. Right, nothing else to worry about. We leave the denominator the same. It's still x dash take 2, still squared. We don't want to actually expand this bracket out with the squared, by the way, because then you'd have like x dash squareds and x dashes and stuff, and it would be horrible. You don't really want to see the letter x in more than one spot. Okay, so we'll leave that squared as it is. Plus, we'll know that it's a truncus by having just an x in brackets squared. So don't actually square that bracket. Okay, 2 more steps to go. Let's take away the 12 to the other side. All right, we're going to take away the 12 to cross that out. Take away the 12 from this side. Again, no funny business going on. We've still got negative y dash on that side. We've still got our fraction on this side. 3 lots. Oh, sorry, 3 on top of x dash take 2 squared. We can just chuck the minus 12 out the back. It's happening after it. And then we just don't want that negative there anymore. So if I'm going to turn that negative into a positive, I'll turn any other positives into negatives and any other negatives into positives. So I'll end up with y dash. This fraction is a positive fraction right now, so I'll just put a negative out the front of it to show it's now a negative fraction, right? That's me flipping the whole fraction. X dash take 2 squared plus 12. Right, we have y dash by itself. All right, there was a bit of stuff we had to do. We had to do a little bit of transposition, or a fair bit of transposition in this case, but we do now have y dash by itself. Okay, all that's left to do to get our final equation and our final answer is just scrub out those dashes, right? Replace y dash and x dash with y and x. So if you're drawing in pencil, you can now just rub those out, and we've fixed it, but let's just write it out just to be satisfied with a job well done. Y equals, we've got this negative fraction, it's got a 3 on top, it now has an x, take away 2, that's squared on the bottom, and that's a plus 12. All right, we can now see we have a basic truncus that has a side-to-side movement going on. It's got some dilation going on. It's got some reflection going on, and another translation going on. And matrices helped us get from the original equation all the way up here. And matrix methods helped us get our answer down here. And that is our last example. So hopefully you've enjoyed that and your heads haven't exploded or anything like that. We've got a big chapter of work to get through. I'll be online waiting to answer your questions. So good luck with it.